Okay, that's good. Minimize this. Close that. I need to identify. Okay. La 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 la. La 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 la. Ha 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 ha. Fundamental trig identities. All you do is study those, right? Oh, baby. Here we go. So, on your own, you're going to, I'm going to show you here. I want you to fill out this section, this one, and the bottom one. You cannot do this one. We're going to learn this one today. But you can do these 4 right here. Or you should be able to do those 4 right there. We'll find out. Whoa. Told you guys to study them. There's a reason I told you to study them. Okay. Take a few minutes, guys. See what you can do with this. Come on. What can I do? Do. Take about another minute. See where you can get. Here. So we're just submit, submit, submit. All right. All right. So this is not a quiz, right? This is a warning because tomorrow there is a quiz. But this should let you know where you are on being ready for that quiz. Okay, so we need to go through this, and then I will tell you right now, this section here will be included on tomorrow's quiz. The section I said you couldn't fill out yet. So we want to go through this and fill this out. So the first ones there, the reciprocal ones, those should be the easiest of all. So the sine of u is equivalent to 1 over the cosecant of u. And the cosine of u is 1 over the secant u, and tangent is 1 over cotangent u. Cosecant's 1 over sine u, secant's 1 over cosine u, and cotangent's 1 over tangent u. Those should be give me points. Okay? The quotient identities should be pretty easy as well. The tangent is sine u over cosine u, and cotangent is cosine u over sine u. Okay? All right. Pythagorean identities is completely blank. How many are there? 3. There are 3 of them. Okay? The first one that I taught you was sine squared u plus cosine squared u equals 1. Of course, the order of sine squared and cosine squared doesn't matter. Okay? That was the first one I did with you. The second one, the second 2 I did at the same time. I'm not sure which order I did them, but I probably did it this way. Was 1 plus tangent squared u is equal to secant squared u. That was the second one of the second ones. And then the third one was 1 plus cotangent squared u is equal to cosecant squared u. So those are the 3 Pythagorean identities. Okay. Then down at the bottom, even odd. That was the whole thing about, you know, where is it symmetric to? Is it symmetric to the y-axis, or is it symmetric to the origin? Okay. So does anybody remember on this Does anybody remember how many evens there are? 2. There are 2 evens, and then there are 4 odd. Okay, so let's start with our even identities. First one is cosine. Okay, so you could put cosine. It doesn't matter what variable you use. You could use u's, x's. Since I've been using u's, we'll stay with that. That would be the cosine of u is equal to the cosine of negative u. All right. And then if cosine isn't even, its reciprocal automatically is as well, which means what? Secant. The second one is secant u is equal to the secant of negative u. Okay, so those were the ones that were called the even functions. Why is that blue stupid thing there? Okay. Then the odd. All right, so here we go. Yeah. It doesn't matter what you use. It's a variable. I don't care about that. And on tomorrow's quiz, you can use whatever you want. I don't care. Here we go. First one. Negative sine of u is equal to sine of negative u. And if you get the first one right, the next 3 are the same style of identities. Negative cosecant u is equal to the cosecant of negative u. Negative tangent u is equal to the tangent of negative u. And negative cotangent u is equal to the cotangent of negative u. Right? So those were some that we had already done. And today, once we've added these, we're going to start looking at how we're going to be using these. Yeah. No. Reflexive property says it doesn't matter what's on what side. Okay. All right. So we're going to be looking at how are we going to start using these more and more in here. And we are going, right now, the plan is to have a test by next week. Now, look, I know it's going to be fast because we don't have school next Tuesday or Wednesday. Because Tuesday is election day, you don't come. It may not happen. It may end up being that the test is like the following week, right towards the beginning. But we're going to see if we're able to get a test in by the end of next week. And I will make sure, if I don't feel like you're ready, I won't do that to you. But I'm trying to get you through everything I need to get you guys familiar with for next year. Okay? All right, so I'm curious. Overall, did anybody get all of those right? You can just be honest if you did. No? That's fine. By tomorrow, you need to know them. Okay? You're going to need to know these. So we're going to write these down here in a second. And before I write those down, I'm actually going to go ahead and look at graphs. Notice what they're called. These identities that aren't filled out on there. They're called the cofunction identities. Cofunction. So what do you think is the cofunction to sine? What function has co in front of it that would be sine? The cosine. What will be for like secant? It would be what? The cosecant. What about tangent? It would be the cotangent, right? Those are cofunctions. So all you have to do is put the prefix co in front of it. Yeah. Oh, you can do whatever you need to. That's fine. Yeah. Yeah, you can do that. And if you need to like angle your desk, go for it. Okay, so what I want to do real quick is I'm going to put a graph up here. So everyone's just going to hang tight here for a second. And all you're going to have to do is follow along with me here. So here is Desmos, okay? Beautiful. Don't worry about all those orange things. Those are supposed to be there right now. All right, so what I'm going to do is I'm literally going to see what I've got here. I've got it. Radians, perfect. Okay. So I'm going to turn on. Everyone should know what a sine curve looks like by now, I would hope. Okay. Notice that I have cosine right below it. That's the co-function to it. I'm going to type, not even type, I'm going to paste it here, and I want you to see what happens here. Okay, so I'm going to put cosine of pi over 2 minus x. This is sine of x. This is cosine of pi over 2 minus x. What happened? Tell me about what you see on the graphs. They're the exact same. Exact same. Okay. Let's try the cosine here. Here's cosine x. I'm going to type in sine of pi over 2 minus x. Let's see what happens. They're the exact same. This is weird. Let's go to tangent. Here's tangent x. Let's do cotangent of that pi over 2 minus x and see what happens. They're the exact same. Let's turn on secant x. Let's do cosecant of pi over 2 minus x and see if they're the same. Oh my goodness, they're the exact same. Let's do cosecant of x, and let's do secant of pi over 2 minus x. They're the exact same. Wow, this is really weird. Cotangent and tangent of pi over 2 minus x. They're the exact same. So what do you think this property says? Sine of u is equal to what? Cosine of pi over 2 minus u. As a matter of fact, every one of these is the exact same way. Sine u is equal to cosine of pi over 2 minus u. So cosecant is going to be what? Equal to, what's the cofunction of secant? Secant, oh, it's going to be the secant of pi over 2 minus u. Oh, cosine, what is the cofunction to that? The sine. I mean, really all you have to know is what cofunctions are. And you're always going to put what? Pi over 2 minus u. That's it. Secant u would be what? Equal to cosecant of pi over 2 minus u. Tangent u, oh, that'd be cotangent of pi over 2 minus u. And cotangent would be tangent of, I mean, the nice thing here is if you really know one of them, you know them all.
For this, you gave us like cosine u cosine.
Say what? Oh, I already had what the cofunctions were. That was okay. I was being nice, I guess. Tomorrow? No. That was a high. Really, I meant to get rid of those. I don't know why I left them there. Okay. So, boom. That's the other one. And really and truly, all you have to remember is what? A function is equal to its cofunction of pi over 2 minus whatever the variable is. That's it. It's not a lot to remember, guys. This last part is this cofunction identities. Okay? So all of those tomorrow you will be responsible for. Now, I will tell you on the quiz tomorrow, which will look very much like this, I'll try to give you a little more space. I will have sine u cosine. I'll have what I had here will be exactly the same. What I had here will be exactly the same. There will be nothing for Pythagorean identities because you have to do it on your own. The cofunction, I will have the sine u cosine. I'll have just the left-hand side here. The even odds, I'll have nothing. So you have to remember those things on your own. Okay? All righty. Anybody have any quick questions? No? Yep. Geiger. Yeah, I mean, that's a small thing. But you always it's always sine or cosine or cosecant of something. So there should be a variable there. Okay. There should be a variable. All righty. Let me go ahead and let's get going here today. So I'm going to get rid of this and this and this. Get rid of that. I want to get rid of this, and I want to get rid of this, and I want to get rid of this, and get rid of this. So here's what we're going to be starting today. It is known as analytic trigonometry. Okay? Analytic trigonometry. So we are going to want to be able to use trig identities to do some things to help us out in this class. All right? So before we even do anything that's analytic trig, does this kind of thing look familiar at all from last year? Yes. Okay. What is this? Yeah, it's a two-column proof, probably you called it. Maybe you didn't say it was a two-column proof, but it's a proof, right? Somebody tell me how you did this. Tell me what, like, let's just refresh our memory because we need this kind of mindset again a little bit. Okay? Yeah. Like what did you do first when you got a problem like this? You write down the givens. You mean like you wrote them on the statements over there? Before you wrote them down in the statements, did you do anything else? I'm just curious. If you didn't, that's fine. I'm just asking. What's that?
I would like map out like what stuff lined up.
You mapped out on the picture. Oh, so you marked the picture up using the given information. Gotcha. So really what you did was, you're telling me, is you tried to figure out the proof informally on the picture, and then you formally wrote it down over there. That's most likely what you did. So let's go ahead and do this. So this first one here, what is this telling me? This is a review. What does it tell me about TM and TH, those segments? They're congruent, right? So TM and TH are congruent. I'm going to double hash them. Boom. All right, great. Then it says triangle MAH is equilateral. So what can I do down there in triangle MAH? All of them are the same. Okay, now let's look at what I'm trying to prove. I'm trying to prove that triangle TAM, here's TAM. I want this triangle congruent to this triangle, right? That's what I'm looking to do. You guys had methods for that, right? You had what? SSS, SAS, ASA, AAS, right? Side, 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 angle, side, angle, 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 side. You may have had hypotenuse leg as well, right? Those are things you use. There were shortcuts for proving triangles congruent. So far, is there anything else I could do? Yeah. Yeah, TA is shared by the two triangles, right? So I could say what? That TA is congruent to TA. Oh, so the triangles are congruent by side, side, side. And then you had to come over here and you had to write everything down. And you wrote the statement and then you had a reason over here. And your reasons were what? They could be postulates, theorems, corollaries, definitions, right? Algebraic properties like reflexive property, transitive property. Those were things that you used to do this. So someone else could follow along and understand what you did. Okay? Now, so in this class, we're going to be doing this thought of trying to prove something is true. But what we're going to do is not two-column proofs. We're doing algebraic proofs. We're going to be doing algebraic proofs, okay? All right, so let me put an example of an algebraic proof on the board. I'm going to write this down here so I don't mess this up. Aha, here we go. Okay. So if I said to you the following, if I said prove this, if I said to prove that's true, Okay? How would you do that? How would you prove that's a true statement? Krista? Oh, so you want me to move things from the left to the right. If I do that, I'm changing my equation, right? I don't really want to change both sides of my equation like that. I want to prove that the left side is equal to the right. Yeah, I wouldn't just solve it, I would do what? Simplify, right? And by simplifying it, what do you use? You use algebraic properties. Like, what would you have to know on the left-hand side? What properties would you need to know on the left-hand side to show this is true? I can't hear you. PEMDAS. You need to know the order of operations. That's all you'd have to know to prove this is true. So what's the first thing you would do here? Parentheses. So you would write down this. 2 times what? 8 squared minus 8 equals 120. Boom. And then if somebody said, what did you do? You could just say what? Oh, well, I added inside the parentheses. I did parentheses first. Then what would you do next? Then you do the exponents. So you'd say 2 times 64 minus 8 equals 120. So you said, okay, on order of operations, I always do what next? After parentheses, I do exponents. Boom, did it. Then I would do what? Multiplication. 2 times, okay, that'd be 128 minus 8 equals 120. Why'd you do that next? Because the next order of operation is, hey, if I got multiplication and subtraction, I always do what? Multiplication first. And then I would do what? Oh, I would just do the subtraction here and get 120 equals 120, and I've shown that they are equivalent. Now, I didn't do anything to the right-hand side at all. I worked with one side alone and made it look like the other side. And all I used here was order of operations. Okay? That's what we did. So one of the things you're going to be doing is trying to show that equations are true. But you're not going to be using order of operations. You will be using techniques like replacing trig identities with equivalent trig identities so that you can simplify things together. Okay? All right, that's one of the things. So here's what we're going to be doing in here. All right? So there are 4 ways in which we're going to use the fundamental trig identities. There's 4 ways we're going to use these things you have in front of you. All right? Here we go. The first one is we're going to evaluate trig functions. Now, you've already been doing that. Remember that review sheet I gave you guys? And I asked you, and I gave you like the sine was this, and a cotangent was this, and you had to find the missing ones. You were actually using trig identities. You were using reciprocal identities on that, weren't you? To evaluate. So you can use the trig identities to evaluate, all right, different trig functions. Simple enough. We've already been doing that. The second thing is to simplify trigonometric expressions. To simplify. All right. Now, think about this. Think back to logarithms. Remember back in logarithms, we had properties. We had the product property, the quotient property, power property. And we did that so we could take a bunch of logarithms and make them down into one. We used those properties to simplify them. We can use trig identities to simplify trigonometric expressions as well. Make them look nicer, neater, smaller, easier to work with. The third thing, to develop additional trig identities. We can show that new things are true if we know the original fundamental identities. We can say, you know what, if this is true, I can show that this is also true. Watch, boom. And the final thing is to solve trigonometric equations algebraically. To solve them algebraically. Okay? Those are the things that we're going to be doing with our trig identities. All right. Now, I'm not going to ask you that. What are the 4 things we can do? That's not a quiz question. That's informational only, guys. I'm not going to quiz you on that. So, oh, somebody. What is this? Thought I was screen sharing. Screen share. Why is it on that one? All right. So let's keep going here. Now, this is actually a Pythagorean identity. I gave this one to you, right? This is one of your Pythagorean identities, okay? But let's say you didn't know this Pythagorean identity, and I said, verify this equation is true by only working on the left side. So it's kind of like the thing I just did with, hey, show that this is equal to 120 by only working on the left-hand side. Same idea. I want to show that this is true. And I'm only allowed to take this side and work with it. Okay? So I have to use other. I cannot use the Pythagorean identity of 1 plus tangent squared u equals secant squared u in the identity I'm working on. So let's do this. Talk to me. This is where we start seeing who can think algebraically in order to rewrite things in equivalent forms. All right, so I'm just going to write this left-hand side down. 1 plus tangent squared u. Okay? So can anybody tell me anything at all that I could do with this to change its appearance but not change its value?
1 plus sine squared u over cosine squared u.
Quotient identity. Love it. He's using the quotient one. That tangent is nothing more than sine over cosine. So he said, I'm going to rewrite this as 1 plus sine squared u over cosine squared u. Okay, I like that. Now what?
Write 1 as cosine squared u over cosine squared u because anything divided by itself is 1.
Perfect. Just going to take 1 and rename it however I want. How did she know cosine squared? Because that's the denominator of the other fraction. So we're going to make this cosine squared u over cosine squared u plus sine squared u over cosine squared u. All right, boom. Now what? When I add fractions, what do? Add the tops and leave the bottom alone. So what do I get here? I get cosine squared u plus sine squared u over cosine squared u. Is this something you know? Tangent squared u? Careful. What's cosine squared plus sine squared? 1, right? It's 1. So now I get what? 1 over cosine squared u. Hey, now I could use the what? Reciprocal identity. 1 over cosine squared u is? I did it. I showed it's true. I didn't even touch the right-hand side. I didn't move things from left to right. I worked on one side and renamed it using properties I knew or identities I knew and what? Simplifying things. Okay, when you come back, we'll keep going. This room feels gross. Okay. Oh, I better go do that. Like I'm waiting for you. Walk down.
Because cosine squared plus sine squared equals 1 in the other Pythagorean theorem. Because if you look at the other Pythagorean, then look at the paper. You see it? No?
Oh, the other Pythagorean? Oh, what? I thought it equaled 1.
Sorry, I'm going down.
Oh, does it?
I don't know.
That was the one I did on myself. So it equals 1, not the edge of the order. No wonder I think we got the rest of them.
We got it.
What do you have to run, Brady?
Mile.
Did you get 4th out of 5?
I don't know. They put me at the anchor.
No. Oh, is it like a reason?
Yeah.
Oh, yeah. Mr. McGuire. That's my country.
It's just stuff where you No, it's not. No. This morning when I looked at it, it's like doesn't matter anyway. I get to leave right after.
So once you run, you
The first man.
well, that's good. So you don't have to wait. The 4 by 4. It's 2 ways.
Literally.
That's we always grade 4 by 4. We always eat. Couldn't eat anything. I just had to sit. I mean, I'd rather be
No, we'd always lose.
No, we would.
So this is.
It is the last, that's the very last minute. Because you would cramp for it, and you really die.
I always run like the mile before. And the miles are going first.
Because you probably had other.
Yeah, and we get an early
When do we?
It's in length.
I'll just say I'll do that.
It's supposed to start. I'm only gonna be there till like 4:30.
You know, I might do that. Say when they collect the trash, from 11, read this, just stop.
And I'm the last person on my. It's a distance medley. Yep. 4, 8, 12.
Oh my gosh. Still, I have to know like what's like.
What it is,
Like Cobra, Cobra, just add up.
Make sure you put like the reflexive stuff in front of it to sleep.
Like the set or
I got that one.
years.
And then there's one where it's like, I wonder if he drives.
Oh,
It's extra credit, I got them all. You literally just conjugate it in the future tense for P, and then put question marks.
Conjugate your question mark.
It's like conjugate zero, question mark, question mark.
That's why. Spanish.
Would not recommend.
Yeah, exactly. Says the Lord go to Spanish. Yo, why are you doing Spanish forward?
I have to.
Why do you have to? Wait, why
I
didn't you
I don't want to.
Oh, no, I understand. They use it in Korean for
I quit after 4, and I was doing 5.
five. Apparently, like the fours, you're in the same class. So it's like, if you do 5, then it's like the same as 4, so you do like a little bit, like your speech will be like 30 minutes longer than like your last one.
You go to speak?
My friend's in Spanish 5. He said, good luck, Brady.
I can't speak any Spanish. No.
The listening actually is a little bit. I different. I still don't understand the text. Last year, I would get one. And it was multiple choice too.
Oh my God, come on.
I couldn't understand how they were going to do that. Yeah, it was like she's like having the computer say, okay, I'm putting intensities. It speaks so fast.
Yeah. I think I'm just gonna give them all to you, and then I'll come down and get some from you later on. Yeah, that's perfect. Do that.
How far did they get today?
Well, because just getting the movie started like that, we got 36 minutes. You guys, I'm not sure how far here right now.
No, we are completely flipped.
We don't even speak a single
No,
not a single word.
she usually gets to speak a certain amount of Spanish by the end of the quarter. And it's like 50.
Oh, that is.
All right.
No, I don't want it.
So let's keep looking here. So this is an example of verifying an equation is true. And you're not plugging in some like, oh, I'm just going to plug in and see if it's true for like pi over 2. You actually, this shows it's true for all values of u, not 1. So we don't want to just plug in a value of u and say, oh, it's true once, it's always true. That's not okay. We have to show that it's always true, which is what we just did right here. Okay. Give me a second here. Shop down. La, la, la. Oh, that's the wrong class. Here, I'm going to put a new page up here. Okay, maybe not. Let's just. All right, so here we go. Try this one. See what you can do with this problem. So it says find tangent of u if secant u equals 2. So this would be an idea of evaluating a trig function given a trig function. Given a trig value, evaluate the other one. So if I tell you that the tangent of u, I want you to find the tangent of u if I tell you the secant of u is 2. Okay? There's multiple correct ways of doing this. this, get rid of it, get rid of it. Oops. Why didn't that work? Her. Uh-oh. What's wrong with this? Okay. So any ideas? How's this different than what I had you guys do on your review? Yeah, that's true. I don't mean like earlier today, like on Monday, I gave you guys a review packet and I asked you to find, I said, if given this, like I had sine, I think the first one was like sine was negative 12 or 13, blah, blah, blah. You had to find the remaining ones. How's this one different? What did I usually do to you? Like, if I gave you this, remember me doing this to you, and I said find the remaining ones? You just did this on the review, hopefully, okay? So I'm going to post so you can check those tonight. How's this different than this one up here? Like if I asked you on this, if I said, hey, find the tangent of theta. If all I wanted was the tangent of theta for this, tell me how you would do that. Find what? You would go through and you would say, oh, well, sine is what variables? Y over R. So you'd have to find what? X, and then you would know that tangent is what? Y over X, and you would be able to find it, right? And that's, you're using knowledge there, that's fine, okay? And this had how many solutions? One, right? Just one. How many is this going to have? Two. Why is it different? Why, how are these two different? Yeah. Yeah, this allows you to pinpoint what quadrant it was in. Like what quadrant would theta have to be in right here? If the sine is negative and the cotangent is also negative. Where does that have to be? Quadrant number 4. And there's only one angle in quadrant 4 that would work with that. This is different. I did not give you enough information to do that. So this has 2 solutions. All right. So let's do this. What are the different ways that I could go about finding tangent of u? Are there any identities that have tangent and secant somehow linked together? What's that?
1 plus tangent squared u equals secant.
Oh, so this knowledge that 1 plus tangent squared u equals secant squared u. All right. That's very true. It's a great one. I like that. Let's use that. How am I going to use that? I first have to find out what secant squared is. So what is secant squared u going to be? 4. Oh, so then here I can make this 1 plus tangent squared u equals 4. Now let's solve this. What would I do next? Subtract 1. Boop, 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 boop. Woo. Then what? Take the square root. Ciao. And if I take the square root, how many roots do I have to account for? 2. Done. There's my answer. That's my answer right there. It could be positive radical 3 or negative radical 3, depending upon what quadrant it is in. Now, what do I know? If the secant is positive, what 2 quadrants am I possibly in? If the secant is positive 2, What two quadrants am I possibly in? 1 and 4. That's why in quadrant 1, the tangent will be what? The positive. In quadrant 4, the tangent would be the negative. Okay, so we used a trig identity to help us figure this one out. That's another way we use trig identities. Okay, a second way we can use them. All right, I just want to simplify this. That's all I want to do. I want to simplify it. Notice there's no equation. It's just got secant x minus tangent x times sine x. I want to simplify it down as far as I possibly can. All right, let's do that. Anybody have any thoughts of what you might want to replace with an identity? Ryan, what do you think? Tangent x, what do you want to make it? Perfect, let's do it. Here we go, we're going to go with that. So I've got secant x minus sine x over cosine x times sine x. Let's just simplify that. Let's not replace, let's simplify that. That's what now? Secant x minus what? What am I going to get here when I simplify this? I'm going to get sine squared x over cosine x. All right, talk to me. What do you think? Love it. Secant 1 over cosine x minus sine squared x over cosine x. Okay? So what's my numerator going to be? What's my numerator? 1 minus sine squared x over cosine x. All right, now, here we go. Are you ready? 1, this number right here, is equivalent to what trig identity? What trig identity has 1 in it? Cosine squared plus sine squared. Then minus that sine squared x over cosine x. What happens up here? These are going to go what? Bye-bye. So what am I left with now? Cosine squared x over cosine x. You agree with that? And what does that come down to? Laws of exponents. Cosine x. Boom. Done. That is the same as that. Which means if I had done this to you, and said solve this, guess what you'd want to do? You want to go to this first and make your life a lot easier. That makes sense? There's a reason. We don't want to have, if I have an equation, I don't want multiple trig functions in it if possible. I'd like to get it down to 1 if I can. I don't want to have 3 different ones in it. Okay? Don't want that at all. So, being able to simplify, make things easier to work with. Right? Let's try this one. Simplify. See if you can simplify this one. And while you're doing that, what I tried to, you can talk about it. I scanned the homework, and for some reason it's not showing up on my email.
I think.
Yeah.
Okay. Now, guys, remember, when you're doing these, one of the beauties of these things, like when you're doing two-column proofs in geometry, two people could prove it two different ways potentially. So when you do these, there's not just necessarily one way of simplifying it. You could maybe go about it different ways. Okay? Anybody have any thoughts about what they did first? No? No thoughts at all? So this is where we start using algebra skills from algebra 2 and algebra 1 now with our trig. What's the GCF? Sine x. Factor it out. What am I left with? Cosine squared x minus 1. Oh, here we go again. What can I do on the inside? Cosine squared x, and I gotta be careful. Minus, if I replace 1 like I did last time, it has to go in parentheses because I want to subtract all of it. Minus sine squared x, what? Plus cosine squared x, right? There we go. Sine x times. Okay, what's going to happen here? Cosine squared x minus cosine squared x, it's going to be what? What? It's going to be gone, isn't it? This negative, when it goes through here, they're going to cancel. So what am I left with in here? Minus sine squared x. So what do I end up getting then? Negative sine cubed x. So this one, I used the Pythagorean identity, but before I did that, I just used factoring skills from algebra. So we need those algebra skills that we used before, and we have to be able to try to use them in here as well to rewrite. So not every step is using an identity. Some steps are using skills from algebra like factoring or renaming a 1 as a fraction or what? Combining like terms. Those are things you have to be able to do still. Okay? All right. Any questions on that one? No? Good. Now this is different. How's this different than the last one? This one has an equal sign. Okay, here's what I want you to do. I want you to show or verify that the left-hand side is equal to the right-hand side. So in other words, you need to take this and make it look like that somehow. And you're only going to work on the left-hand side. See what you can do. See what you can do. let's go here. Let's go here. Boom. Assignment 5.1. Oops, I don't want to do that yet. I need to do this. Oh, let's see how that looks. Perfect. Documents. Five point one. And let's go here. Add file. Browse. Talk about it with each other, guys. Don't right now. You're just starting to do this. So bounce ideas off of each other. Think about what you're doing here. Oh, boop. Discard draft. Wrong. Let's create material. 5.1. Description.
Yeah, I don't know.
Okay. 3rd, 5th. Post. Post.
I think that might be a bit easier.
And one thing, some things you guys have to learn to do is try. If it doesn't work, try something different.
We have secant squared and sine squared, which would be sine squared over 2 equal. I don't know if you're right.
Hold on. Just kidding, it's not. Okay.
What could the kids want? Okay, what did you think first?
You want to be like people kind of.
So I'm trying to do like something over something. So I did secant x over x, and then there's secant 1 plus sine x over. Should be able to do I could just take it out.
I don't know how you go about that. Well, I'm gonna fail.
What's going on?
I mean, you can make it.
Still in the next one. It's like 3 days.
What weeks of, you know what?
No.
And Tuesday.
That's fine.
We'll wait.
This has to usually go, so.
When he says that we don't have equal one, but you get not equal left. I'm so hungry.
Anybody got any great ideas here? Any ideas over here? Any thoughts? No? You're doing so, that's good. Any thoughts over here?
I got myself.
Oh, come on, Chris. Sorry.
I need to just get it right now. Because we know.
Yeah, but then I have no idea where to go.
Yeah. About $5. So I feel like there should be some sort of ratio. Same amount, right? Wait, if you didn't go through the signs, that's the bottom. You cannot control that column. Here then. So what? I got it. I literally got it. Okay, so what's the opposite of sign? Cosecant.
Oh, is your head hurting yet, bud? Are you okay? Okay.
It's because
This is making it hurt more? Good. I like that. This is a healthy hurt. What in the world are you doing?
So both of them are the same except for one.
No, I think we got it wrong.
Okay.
It's fun to find.
Yeah,
It's you can't solve. There's no such thing.
Can I like simplify that? Like, you know, squared x over.
Somehow get to that? What does that mean? I don't either. Now, look, I know what you're, this is, I don't mind what you're calculus. I think you're gonna have to do so much algebra to do this whole derivatives and integrals. And you won't be able to give this to them if you're just. You
Over and
need to be able to do things algebraically as well. Right?
everything over a sign, right? And so then you can add the.
All right, so anybody have any thoughts how they thought, I mean, what you might, I mean, look, guys, you gotta, here's where you have to be thinking to yourself, as long as I'm doing something that's okay, if it doesn't help me in the end, I've learned something from it. I've learned not to go that route again. It's just like people that invent things. They don't get it right the first time, but they learn from their mistakes and say, okay, I don't want to do that next time. Let's approach it a different way. Geiger.
So I tried to get them both the same bottom. So I did secant x over cosecant cube x plus cosine x.
Whoa, wait. What are you, where did that come from?
Because the opposite of the sign is 1 over cosine.
Oh, so you saying you just basically made this 1 over cosine. To start. Okay, so that's fine. You can, yeah, don't give me, that's a basic starting point then. So he said he turned everything into sines and cosines, you're telling me this. Your first step was you didn't make everything sine and cosine?
So what I did was I did secant x times 1 over cosecant.
So you changed this and used the reciprocal identity. So you made this different and then you changed this as well? Okay, that's fine. You can do it that way. That's a start. So you're using reciprocal identities to start. Perfect. Anybody else do something different? Yeah.
I said that secant is 1 over cosine. Cosine x is over 1, so then it was just over 1.
So you said you made this 1 over cosine x times, and then you said those cancel each other out
They would be 1.
if you multiply them. Oh, but if I simplify this, this becomes sine cube x over cosine x plus sine x plus cosine x sorry, sine x cosine x over 1. That's what I would get, wouldn't I? And you don't cross reduce on addition, do you? You cross reduce if this is what? Multiplication. So I can continue this route. There's nothing wrong with where I'm at right now. I just can't cancel these out. If that was multiplication, yeah, then I could cancel them out, but it's not. Anybody else got an idea?
I factored out the sign from both, so you get
Okay, hold on. Let me do this. We group this, collapse it. We'll just put it here for right now. So you factored the sign out and went sine x times secant x sine squared x plus cosine x.
yeah.
Okay, that's an option. Nothing wrong with that. Okay, nothing wrong with that. Yeah. I'm sorry, hold on. How would I get these the same? I'd have to multiply this one by cosine x over cosine x. I could do that. There's nothing wrong with that. I can rename a fraction. How do you rename fractions? Multiply it by a form of 1. Any one you want. So yeah, I mean, right here on this, if I wanted, I could say, oh, I'm going to take this and multiply it by cosine x over cosine x. So I would get sine cubed x over cosine x plus sine x cosine squared x over cosine x. That would be completely fine to do that. That's just using algebra skills. See, this is where all those algebra skills that we kind of had sitting idle for a while, we need to start dusting them off and using them now. And I will tell you, being able to take things like this and manipulate them algebraically in calculus, that is going to be huge. So you need this skill set of algebration, okay, for things like this. So does that answer your question? Right? Okay. I kind of like where that's going. Why? Why do I like what this is doing right now for me? Can anybody think, what is my thinking here? What do I like? I love that sines in the top and cosines in the bottom. Why? Because tangent is sine over. And I really love that the bottom is just cosine x. If I could somehow get the top to just be what? Sine x, I'd be good to go. I'm looking down the road at what I need to get to. Okay? We're going to keep working with this one. What do I get in the numerator, guys? Sine cubed x plus, this is the last thing, get it out of the way, plus sine x cosine squared x over, oh my goodness, I'm a happy boy right now. GCF in the numerator is what? What's the greatest common factor in the numerator? Sine x. Check this out. Sine x times sine squared x plus cosine squared x all over cosine x. Guess what sine squared x plus cosine squared x is? 1. Woo! Look at that. Now, that path got us there. That does not mean it's the only path to get there. I love that. That is starting to be able to utilize and replace. And if you don't know the fundamental identities really well, this becomes hard. And you also need to be able to work with things and rewrite them in equivalent forms using just plain old greatest common factors, getting common denominators. Those things are all coming into play. Oh, I love that. Love it, love it, love it. That was a good start, the way you went. I liked it. That was good. Good choice. Helped me out. Okay. Now look, listen up. This is what I want you to do tonight. Okay. And I might simplify it. Okay, so your online books, I don't know if they're working or not. I don't even care right now, to tell you the truth. So here's what I've done. I'm just going to be scanning bookwork and posting it. Okay. So if you end up going here, you'll notice it says file what homework. And if I click it, there's a PDF of this, and these are the 2 pages you would need. And you would simply be able to go in and look at the homework problems right here. Okay. So let's look at what the assignment was. The assignment I gave you was 19 through 30 all to start. So let's go back and look at what 19 through 30 all are asking you to do. Here's 19 through 30. This is 19 through 30. It says match the trig expression with its simplified form. So one of these, like secant x cosine x, is equal to one of these things up here. It's a matching. It's basic simplification. Down here, exact same thing. It says match the trig expression with its simplified form. Boom. Again, it's the same idea, a little bit more complex. That's the first section. Can you go ahead and make this, simplify this, and will you find some version of it up here? Okay. The second part I asked you to do, we'll look at here, is 31 to 71 odds. Okay, now, notice what this one says down here. It says use the fundamental identities to simplify the expression. That's what that's about. Over here, look at this one saying. Same thing. This is telling you to factor the expression. Use the fundamental identities to simplify if necessary. I'll tell you what I'm going to do. I'm going to simplify that. I'm not going to make you do all of those. That's a lot. Okay? I want you to do this first section here. This part is very important. On the 31 to 71, instead of doing all of the odds, let's make it 32 to 68, and I want you to do multiples of 4. 32 is a multiple of 4, right? 32, 36, 40, 44. That's a lot less. That's half as many. Yeah. This, I'll put it in the instructions with it, so you'll see it. So it'll say 19 through 30 all, and then I'm going to have 32 to 68 multiples of 4. That will be online. I'll have to just change it here in a second. Come back tomorrow with those, and we'll look at any of those that you want. Okay, that is our goal. Tomorrow, though, the first thing you do when you come in tomorrow is take a quiz. That will be the very first thing you do tomorrow. So let me change classes. Classwork, 5-1 homework. Let's edit this. And bookwork 5-1, 19 through 30 all. (32 through 68) multiples of 4.
This is for happy
Yeah.
hours. I'm not gonna be at school tomorrow.
You're not?
No.
Where are you gonna be?
I'm getting like this surgery on my wrist.
Okay. So tomorrow we're probably gonna be working, we'll probably be doing a lot of this in class.
Okay.
So it'll be on live, it'll be recorded. You can watch me do all of these that you want, and then if I have any extra problems on there, you'll just go ahead and be able to work on them.
Okay, will we have any homework over the weekend?
You might have a little bit, yes, over the weekend. And it would, if what I'll do is, if it's like a worksheet, I'll post it, and it'll be, I post most of those to everybody, so you'll be able to find it online on the classroom, all right?
And then maybe I'll make up that quiz like next week.
Which quiz gets make up still?
Another one that we're taking.
Oh, tomorrow's, you mean? Yeah, that's fine. That's fine. You can do that. Okay,
Not right now. Oh, that's exactly.
So there's like a, it's a rosa in it.
Yeah, I broke this.
So what's happening?
So like, you're going in tomorrow, this one's still open. You're going into like, breaking the.
Oh, is that all?
So your arms are back.
that's not right. One,
They do a big.
numbers 19 through 30, then 32 through 68.
All Friday. So hard.
Have a good one, guys. Okay.